Welcome to our first lesson of the term. As you can see, we're going to be starting with some trigonometry here, one of the most practical maths ever invented. We'll be using this math not just in the trig section of the course, but you'll find that it comes in handy in later sections as well, and it'll probably come in handy later in your life as well. It's great stuff. Usually I start this lecture, if I'm in a classroom, by handing out a table of the trigonometric ratios. So I actually posted it underneath your syllabus if you want to print one out for yourself, but I've got it right here too. Woo! So this is what I usually print out. So A stands for angle, and this is 0 degrees, 1 degrees, 2 degrees, 3 degrees, and so on. And then we have here 3 columns. That's interesting. This, SIN, actually stands for sine. So it's a 3-letter abbreviation of a 4-letter word. Anyway, it's sine. It's a ratio of two sides. I'll show you this in a minute. COS stands for cosine, and TAN stands for tangent. And so we have these 3 trigonometric ratios. What am I talking ratios? Okay, let's come back to our main page of notes. Ratios. What we do is we make ratios of two sides of a triangle. So like if I wanted to make a ratio of opposite side over hypotenuse, I would take the length of the opposite side, divide it by the length of the hypotenuse, and you'd get some decimal number or fraction, and that would be, it's a ratio, right? One number over the other is a ratio, and it would be one of our trigonometric ratios. Now, in order to define what is this sine, cosine, and tangent ratio, the first thing we got to do is we got to be really good at naming the sides of a triangle, a right triangle. I should probably point out, we're talking about right triangles today, and for the next few days, nothing but right triangles. So, usually the hypotenuse is the side everybody knows. It's the big side, right? If it's a right triangle, again, you have to have a 90-degree angle in there somewhere. If it's a right triangle, then the longest side is the hypotenuse. Cool. Okay. You could also look at it as it's the side that's across from the 90 degrees. If you ever have any doubt, like if two sides look like they're almost the same size, which one's the hypotenuse? It's the one that's across from the 90 degrees. Okay, so just remember that. That's the hypotenuse. That's the easy one. Okay, this side's called the opposite side. Opposite from what? Opposite from this angle. So theta, that's a Greek letter for the th sound, th sound. You have to label either this angle or this angle, right? One of them has to be labeled, has to be our angle of interest, so to speak. And so this one happens to be labeled, and so this becomes our starting point, our reference point, whatever you want to call it. And we name the opposite side with reference to this angle here, and this is very important. Which side is opposite depends on which is your theta. Well, if this is my theta, that's the opposite. Why? Well, for one thing, it's way over there, right? It's way over there. Way on the opposite side of the triangle. Get it? I always think about if this is like a triangular lawn or something. If I'm starting here at the angle, I got to walk across the lawn to get over there to the opposite side, the opposite fence, the opposite sidewalk, whatever you want to call it. You have to walk through the middle of the triangle. Start at theta, walk through the middle of the triangle all the way to the opposite side, and you will find the opposite side. Works every time. This side, as you can see, is called the adjacent side. It's kind of like the leftover side. That's how I do it. It's the leftover side. Or you could just say, look, I'm standing on it practically, right? I'm right there on the adjacent side. Of course, you're standing on the hypotenuse too, but it's not the hypotenuse. It's the other one. So the other one you're standing on, that's called the adjacent side. So again, this diagram on the right is emphasizing that fact. Look where the theta is this time. Now the theta is over here. Here's my come on, you stop moving around. Okay, here's the 90 degrees. So it is a right triangle, so I can do this kind of stuff. So there's my theta. So I go all the way across through the middle, walking across the lawn, so to speak, to get to the opposite side. That was the opposite side over there, opposite from this angle. But this is the opposite side for this triangle because it's opposite, well, for this angle really, because the angle is up here. Okay, so again, the opposite depends on where's your vantage point, where's your theta, which side is labeled. This, of course, is the hypotenuse. It's the biggest side. You could say you have to walk across from the 90 if you want. I've never heard anyone say that, but you could do that. It's the longest side, and then of course the leftover is the adjacent. You're standing right on it, not the hypotenuse, the other one. You're standing right on it, the adjacent side. Okay, so this is how you have to identify your sides. Hypotenuse is easy. Opposite, make sure you're going all the way through the triangle to the opposite side to get there. Leftover is adjacent. Oh, look. Look what I wrote here. How do you find the opposite side? Well, you could pause if you want to, and I just told you how to find all these three sides, right? So what you want to do is, in your own words, put something like, I don't know, walk across the middle from theta to the up. Well, you're never supposed to use the word in the definition, but you know, to the opposite side. Okay, and you can label, you can put your own words in here. Your own words are always going to be more easily remembered than my words usually. So yeah, so that, just make sure you can label the sides of a right triangle. Again, right triangles. So now that we can define the sine, or now that we can label the sides, we can define sine, cosine, and tangent ratios. So I'm going to do this in two ways. First, I'm going to draw a nice little triangle. It has to be a right triangle. It has to have a 90-degree angle, right about there. I'm going to label this my theta, just because, no particular reason. And I'm going to say, okay, remember, this was the hypotenuse. I'll just abbreviate it, HYP. Walking across the lawn here, you get to the opposite side, which I'll abbreviate OPP. And then this leftover side here, you're basically standing on it, is called the adjacent side. Okay, let me get a different color out here. Green. The sine is defined as take the opposite side and divide it by the hypotenuse side. You know, the opposite side has a certain length. You're dividing lengths is what you're doing. So the length of the opposite side is divided by the length of the hypotenuse. We can write that this way. The sine of some angle theta, again, the theta matters, which one's the theta, but the sine of the angle theta is the opposite side, and that's why theta matters, because it tells you which side is opposite, divided by the hypotenuse side. Okay, that is one of our three big trig ratios. The sine is going to be some number that's the ratio of the opposite of the hypotenuse. Now let me just come up to our table for a minute. Remember that table I handed out? What's this saying? This table is saying that if you happen to have a 10-degree angle, then if you take the opposite side's length and divide it by the hypotenuse's length, you'll have 0.1736. Another way of saying it is the opposite side is 17.36% of the hypotenuse. Something like that. So it's telling you relative dimensions. If I had a 15-degree angle there and I looked at the cosine, oh my gosh, look at this. The cosine, which is the ratio of adjacent over hypotenuse, is 0.9659, meaning the adjacent is 96.59% of the hypotenuse, and so on. So the ratios are giving you relative dimensions is what they're doing. So let me get a little ahead of myself. What was the cosine? The cosine, as I was just saying, is when you have the adjacent over the hypotenuse. I guess I should have defined that first before I started talking about it, but you kind of get the idea. So this is the opposite over the hypotenuse. This ratio is called the sine. If you take the ratio of adjacent over hypotenuse, this ratio is called the cosine. And this is kind of, these arrows are kind of how I picture it myself. I always think of the sine as a sort of an arrow motion. I'm coming from the opposite and I'm going over the hypotenuse like this. I'm taking this side and I'm dividing it by this side to get the sine. Whereas the cosine, I'm making this kind of a motion. I'm coming from the adjacent side over the hypotenuse. I'm taking the ratio of adjacent over hypotenuse. I'm getting the cosine. And I should put one more ratio in here, and the other ratio is the one where you go like this. Opposite over adjacent, and that's called the tangent. So the tangent of the angle is the ratio of the opposite over the adjacent. And you could look up values of tangents for different angles and say, oh, so I guess the opposite is certain percent of the adjacent because that's what the tangent ratio is for that angle, blah, blah, blah. Those are our three trig functions. Now there's two basic ways that you could memorize this. And by the way, yeah, you really should memorize this. Your life will be so much easier. You put a little effort into memorizing this. What should I say here? When I memorize it, what I did is we had a picture on the wall in our classroom when I was a student. We had a picture on the wall that was something like this. Actually, it was 3 separate pictures. It kind of went like you had a picture like this that said, hey, that's the sine. We had a picture like this that said, hey, that's the cosine. We had a picture like this that said, hey, that's the tangent, right? You could do pictures like that. You could even memorize these motions. How do I memorize this motion? I say, I'm here. I got to reach my hand all the way through to the opposite side of the triangle, grab that side, and come over the hypotenuse. See? This one, I'm kind of starting at my jaw, my face almost, and I'm taking the side right here, it's right next to me, right next to my face, and I'm grabbing that side and I'm going over the hypotenuse. So that's how I make a cosine. It's kind of like an Italian thing. Hey, Tony, cosine. Yeah, if you know the motions they make with their hands, you know. Anywho, and then we got tangent is when you reach all the way through to the opposite side and then you come slap yourself in the face. This is called the tangent. It has nothing to do with the hypotenuse, is one way to remember it. Tangent has nothing to do with the hypotenuse. It's the opposite over the adjacent. Just hit yourself in the face. Grab this side. Gotcha. That's one way to do it. It worked for me. But again, I was going into this classroom like every single day for, what's going on, for like a long time, and so it kind of burns in. There's a interesting little, I don't know what you would call this, starts with an MN, I think, mnemonic or something, and it goes like this, and you may have heard this before. SOH CAH TOA! If you can spell the words SOH CAH TOA like that, then this is a shortcut for all of these formulas. Sine is opposite over hypotenuse. Get it? Sine is opposite over hypotenuse. Ain't that something? Cosine is adjacent over hypotenuse. Okay, see? Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That's right. Tangent is the opposite over the adjacent. So that little word, SOH CAH TOA, or I think of it as 3 little words joined together, but SOH CAH TOA is basically contains all of this information in one little phrase. So that's a good way to start. When you're starting, that's what you want to start. After you've done trig for a while, these motions will be pretty much just burned in, and you won't even be thinking about which side is who. You'll just say, oh, it's this way. Yeah. Hey, Tony, cosine. You know, you just be thinking like that. But for now, we can use SOH CAH TOA. So I'm going to demonstrate the use of SOH CAH TOA on some triangles here. So what do we got here? Looking at this triangle on the left, let's see, let's go back to, we'll go back to blue. Here's me. This is my point of view today. I'm in a right triangle and I'm over here. I'm Mr. Theta. So I noticed that over here, I know what the opposite side is, and I also know what the hypotenuse side is. Now, this starts with an O, this starts with an H, right? So you look up here and you say, well, O and H, that's in the sine word. So this is a sine. It's a SOH triangle, I guess you might say. You would actually say that the sine of theta is 3 over 4. You can divide that and get 0.75. So what is this good for? Well, if I know the sine is 0.75 and I got a trig table, and I do, I can come up to the trig table, and the sine is the first column here. So I can look in the first column. I'm coming down here. I'm looking for 0.75, which apparently is, I have to go over to this side. It's somewhere around here. So it's something like a 49-degree angle. Now, good trig tables, they'll have 48 degrees, 48.01 degrees, 48.02 degrees, and so on. This one's just a short table, but anyway, we know it's about 49 degrees. If the sine is 0.75, the angle is about 49 degrees. So we can say, hey, where am I? Hey, I'm going to say it. Okay, hey. So from the table, pardon me, theta is about 49 degrees. Big smiley. Isn't that something? You can navigate ships like this. Here's another triangle. Here's Mr. Theta, that's me, and I'm looking at this side, and well, this was the opposite, but this is the adjacent actually, right? We know this is the hypotenuse. This is not the opposite, so it's the adjacent. So I've got an A and an H. Now back up to your SOH CAH TOA word. I got an A and an H. That's the word in the middle, the cosine, the CAH. Cosine is adjacent over hypotenuse. So this is one of those CAH situations. And so I can actually write the cosine of that angle is, it's the adjacent over the hypotenuse, 3 over 4, which is 0.75, of course. And now we look in the table, and we look in the cosine column, and we say, wait, the cosine is 0.75. I'm coming back up. Cosine, which column is that? That would be the second column, the middle column. I'm coming down this column, looking for 0.75. Where are you? Where are you? Looks like it's just about there. So if I look up, the angle is actually 41 degrees. Okay, 41 degrees. Come on, come on. Let's go back there. There it is. It's about 41 degrees. About. Smile. Okay, cool. And here's another one. As you might guess, we've got one of each kind here. That was a sine, that was a cosine. Are you kind of expecting a tangent? I am. Okay, so that's a theta. Now how do I know this is a tangent? Because that's my opposite side. Remember, I'm reaching all the way through, crossing the lawn, so to speak, to get to the opposite side. That's the hypotenuse. So this is not the hypotenuse. This is the adjacent. And so I've got an opposite and an adjacent, an O and an A. And once more, if you look at your 3 SOH CAH TOA words, the O and the A are in the T, the tangent. So this is definitely the tangent of theta is the opposite over the adjacent. So I should have wrote TOA. So notice then that these 3 words, SOH CAH TOA, stand for 3 different formulas, and that's the way you set them up. TOA means the tangent of whatever angle you're looking at is, and you put the opposite side's length over the adjacent side's length, just like that. So let's go back to the table. What do you say? What do you say? So I'm going to say table. We're going to get approximately, it hardly ever comes out exact, but looking in the table one more time, the tangent column is the third column, of course, right? The last column. Come on, you. Looking for 0.75. I'm scrolling down. Oh, looks like we got there early. Right about there someplace. So it looks like it's just about a 37 degree angle. So I can come back here. Okay, that's enough scrolling for today, huh? And that's like 37 degrees. About. And we're so happy. Now, let's bring in the calculators, huh? You paid good money for those things, didn't you? Calculators. So those trig tables, even the good ones, even the nice big ones, they've been programmed into your calculator so that you can use a button or two in order to figure this out. So when you get to this point here, how do you solve this on a calculator? Well, if you look at your calculator, somewhere in the middle-ish, you'll see some buttons. You'll see one that has an SIN on it, one that has a COS on it, one that has a TAN on it. Okay, that's getting close. But no, I'm not going to press the sine of 0.75. That would be like saying, what's the sine of a 0.75 degree angle? Which we don't have a 0.75 degree angle. We're going the other way. Remember when we were looking up in the table, we were looking the other way. We were kind of back looking up. What you got to do here is you have to do what's called I call it shift cosine. Now if you look at your sine button, you'll notice that when you hit the shift button, it's got this ink on it that says sine, and it looks like an exponent of -1. Achtung! Not an exponent! 9! This is not an exponent. And the reason I have to point this out is you'll notice another button on your calculator. It looks like it's the x to the -1 button. Looks like, oh, I can raise things to a -1 power. Cool. Except that's not what we're doing here. So don't do that, please. Okay, that is not an exponent. It's a notation. It stands for inverse. Stands for inverse sine. Inverse sine. If you ever do any college algebra, there's functions and there's inverse functions. What's a function? Well, you plug things into it. What's an inverse function? Well, you go the other way. So in other words, I take the sine of an angle, I get 0.75. Okay, that's how the sine function works. You take the sine of an angle, you'll get 0.75. If the question is, what angle am I supposed to take the sine of? you go the other way, you do the inverse. So in other words, just remember to do the shift sign is what I'm trying to say. If you're getting the theta out of your sine, do a shift sign instead. So if I go shift sign, shift and then sine of 0.75, I'm going to get 48.6 degrees. So I'm messing up these notes, but that's okay because you don't have to write down everything that I'm writing down. So good, 48.6. So we were saying it was about 49. Look what it is. It's 48.6 to be exact. So over here, let's do this a little more briefly. I gave you more theory than you really needed. What we have is that the cosine is 0.75. If you want the theta itself, you have to do a shift cosine, and that's how I'm going to tend to write these things, just to make it clear that, you know, nobody gets mixed up over that -1 thing. It's you hit the shift and then the cosine of the 0.75. And if I hit the shift and then the cosine of the 0.75, I'm getting 41.4 degrees. We were saying it was about 41. Turns out 41.4 is a little more accurate. Might as well go with the calculator, right? And then here, calculator, can you guess what you would do? You would, because the theta is unknown, we don't know what theta is, we don't want to take the tangent of 3/4. I mean, if I did take the tangent of 3/4, it's going to be crazy. Watch this. I just did it. The tangent of 3/4 is 0.013. Does that look like a 0.013 degree angle to you? No way. So you know you must have done something wrong. You want to do a shift tangent because you're trying to dig out the theta. Shift theta of 0.75. Shift theta. So shift, not shift theta, shift tangent. What the heck am I doing? Sorry about that. Shift tangent. Shift and then tangent and then the 0.75. Point. And it says 36.9 degrees. Go away. 36.9 degrees. So we were thinking 37, 36.9 is more accurate. Okay, so that's how I'm going to do the rest of these. I'm just going to do shift signs all over the place. What do we got? We got 6 more to do. Okay. So now that I got this whole shift stuff out of the way, I think what we can do is we can maybe focus on just, do I have a sine? Do I have a cosine? Do I have a tangent? And that, in fact, is the main thing I want you to get out of this lesson, is I want you to be able to look and say, have I got a sine here? Or is it a cosine? Or is it a tangent? This is a thing that you have to do a bunch of times before it starts to become natural, so it's just worth a day of drill, I guess. So here's my theta. What are these sides? Well, that's the hypotenuse. I know that's the opposite because I can always find the opposite. Myself, I always see the opposite first. I say, oh, there's the opposite. So this must be the adjacent, right? So there's the hypotenuse, there's the adjacent. I've got adjacent and hypotenuse. Let's write this out one more time. SOH CAH TOA. Just keep it there for reference. So AH, adjacent hypotenuse, is a cosine. So we know that the cosine of that angle up here is take its adjacent side, CAH, take its adjacent side, divide it by its hypotenuse side. And if you want, you can stop and make a decimal out of that. Or you can just do shift cosine and just put that stuff in there. Shift cosine of, and then put that in there. So shift, pardon me, cosine. Now I'm going to put the 3 divided by 5.25 in there, close my parentheses, hit my equals button. Bam! 55.2 degrees. I'm rounding to 1 decimal place. That's usually accurate enough. Okay, cool. Let's see. Maybe you're ready to pause the video for a bit and try these remaining 5. Just try these remaining 5. You know you're going to be doing a shift trig function, right? It's either going to be shift sine, shift cosine, or shift tangent. It's a matter of figuring out which trig function and which number goes on top, which number goes on bottom. Those are kind of the 2 things you got to get right. So anyway, pause, try this, come back. Oh, you're back already? Okay, cool. So let's see this one. Here's my theta. You always got to figure out where's your theta. It's over there. So with respect to that theta, this would be the opposite, and you can kind of tell that's the hypotenuse. So OH, SOH, sine. So the sine of that angle is 3.00 over 5.25. So on my calculator, I'm going to do a shift sign of and just shove that stuff right in there. So, shift sine 3 divided by 5.25, close my parentheses, equals, we got 34.8 degrees, rounding to 1 decimal place. Next, here's my point of view. This is my opposite side, right? I can come right through and get to the opposite side. That's the hypotenuse, that's not. That must be the adjacent. AH is one of those cosine things. So I can write that the cosine of theta is equal to the AH. What? Why did I say hypotenuse? Oh my gosh. I'm going too fast. Really I am. Okay, let's erase that. Okay. Sorry. I labeled it right. That's the opposite. That's the adjacent. So which one's the opposite and adjacent? It's the tangent, by gosh. The tangent of that angle is the opposite over the adjacent. There we go. Okay, so theta is going to be the shift tangent because theta is getting plugged into the tangent function. We're not plugging this into the tangent function. No, we're supposed to be plugging something we don't know into the tangent function. Well, how are you supposed to figure out what you're plugging in? That's what the inverse function is for. You do the shift tangent. So shift tangent of 4 divided by 5.25. Boom! 37.3 degrees. Put that in the tangent. Okay, cool. 3 to go. What do we got here? My point of view is up here again. A lot of high thetas. So coming down here, that would be the opposite. That's the hypotenuse. So this is the adjacent. So it's O and A again. So it's another tangent. So the tangent of that angle up there would be its opposite side, O, 12, over its adjacent side, 5.75. So the angle itself then is do a shift tangent. Shift tangent of, put that number in there. So shift tangent of, let's see, 12 divided by 5.75 equals, and then do shift tangent of the answer equals 64.4 degrees. By the way, I didn't make any effort to draw these triangles to scale, so don't let that throw you. Don't look at the angle and guess. That's not going to work. Not for these triangles, it ain't. 2 more. What do we got here? Here I am. There's the opposite side. Woohoo! This is the hypotenuse, by golly. So I've got the opposite hypotenuse, OH. That's a sine situation. So the sine of that angle. Take the opposite, 9.33, put it over the hypotenuse, 12.59. Do one of those shift signs of that goop. So the shift sine of 9.33 divided by 12.59 is 47.8 degrees. Cool. We're rocking and rolling now, folks. Okay, so here's my theta. I know that's the opposite. For some reason, it's always the first side I see. That's the opposite, and we don't know the opposite, so forget about the opposite. This is the hypotenuse. No, it isn't. This is the hypotenuse. Cool. So this must be the adjacent, right? Right. So AH. AH is cosine. This is CAH in our SOH CAH TOA. So the cosine of that angle is take the adjacent, 6.93, put it over the hypotenuse, 8.84. So you're doing a shift cosine of that stuff. And you can do this 2 ways. You can either try to enter it all as a single formula. Sometimes that's the way I like to fly. Sometimes I like to do it piecewise. So I'd go 6.93 divided by 8.84 and hit my equals. And I've got this result. It's like 0.78 something. So that's what I would look up in my table. But rather than look that up in my table, I'll hit shift cosine. And there's an answer key here. Shift cosine of the answer, boom, 38.4 degrees. So if you were matching those angles, then you are so ready for the homework. Now there's a homework set that's posted. It's got 25, 26, 27 questions, I forget, something like that. Be a good drill for you. If you can get to the end of that and get them all right, you've mastered this lesson. I'm talking mastered this lesson. But please make sure you read the syllabus about what you're actually required to turn in. Okay, that's one down.